Last episode, you taught the graph to decide with a conditional edge, one fork, two destinations. But a real agent doesn't decide once. It decides, acts, looks at what came back, and decides again. To do that, an edge has to point backward. Today, you draw the cycle that turns a graph into a React loop, and the guard that keeps it from spinning forever. Here's a straight line graph. Think, then act, then stop. It runs once and dies. An agent that calls a tool sees the answer and can never call another tool is barely an agent. The shape itself is the limitation. So you bend the last edge backward. Act no longer points to the end. It points to think. Now the graph has a cycle. Think, act, think, act, think. That single back edge is React. Nothing else changed. But a cycle with no exit runs until the process dies. So think ends in a conditional edge with a guard. If the model says stop or you've taken too many steps, route to the end. Otherwise, route to act. The loop is bounded by counting, not by hope. Watch the seeded model. Turn 1, 2, and 3 each emit an action. It keeps the loop alive. Turn 4 emits stop. 3 trips around the cycle, then a clean exit through the guard. Deterministic because the script is fixed. The program declares 3 nodes, think, act, and the conditional router, over a state that carries a step counter and a done flag. The scripted model replays 4 turns in strict order. No network, just topology and a script. Think pulls the next scripted turn and writes it into state. Act runs the name tool against the in-memory world and bumps step. The router reads state, stop or step. Max goes to end. Everything else loops back to think. The edges make the cycle real. Think to router, router to act or end, and the back edge act to think. That one backward arrow is the entire difference between a script and an agent. Run it. The trace ladder fills, think, act, observe, again, 3 full rungs, then a 4th, think that lands on stop. The step counter reads 3 at exit, exactly the guard's budget minus 1. The terminal prints the ladder and the headline. Looped 3 times, stopped on stop. Then it runs the whole graph a second time in process and asserts the 2 traces are byte identical. A cycle in the graph is the whole React idea, and a step guard is what makes it safe instead of infinite. You looped, you stopped, you proved it twice. Next episode, tool nodes, wiring that act step to a deterministic environment you fully control.